Good morning, class. This is your instructor. I'm going to be teaching you about the logarithm today, and we have two types of logarithm, basically the common log and the natural log, which is ln, and basically it is to the base e, and we have the common log as well to the base 10. So we don't basically go into this at the first step. As the first step, we are going to be discussing basically what does this function mean and why we actually require. So the reason is basically we want to find out how many times do we have to raise a certain base to get a certain answer. So for instance, if I say that I have to raise 4 to a certain level x so that I can get 64. So that means that 4 is my base and raised to power, or that power is basically known as the exponent in this case. So I have to raise it to a certain level, and if you can just see that if you raise 4 to let's say a power of 3, then you can get 64. But if you want to find out, so then logarithm is the basic formula through which you can, or the methodology to get the value of that power, that how many powers you can raise a certain base. So in this case, 4 would be a base and 3 would be your exponent and 64 would be the actual answer, which you can equate equal to x. So now we take an example here, and I have to skim through the chapter very quickly because I have to go to the questions as well. We have, basically the central idea is that an earthquake can strike any place. Now we need to compare. At certain places it's going to hit hard and certain other places it's going to hit a bit mildly. So how many times can it hit a certain place in intensity, which is going to be many times more than some other place y, you can say. So in place x it can maybe wreak havoc. But and we want to compare now that in place of y, in comparison to that, how much times was it stronger for x. So in this case we would be requiring a log function. So now the Richter scale is a base 10 logarithm scale. Now you have to remember this thing that this scale was created having base 10. Like I told you that base 10 is not usually written. It's log to the base 10 is written and slightly indented downwards, like in negative intercept you write on the coordinate system. So it's going to be like negative y. But it's just slightly indented towards the main value of, or main, this word log that you write. So you're just going to write a bit lower. You can just see here that, for instance, there's a power here, 10 raised to power x equal to 500. Again, there is a calculation in which they're saying that, the difference in the magnitude, how would you represent it in a problem? So 10 raised to power x is 500. And x represents the difference in magnitude on the Richter scale. So how are we going to solve this basically? So 10 raised to power x means that this base is going to be, if you want to convert it into log now, so I'm going to be writing log. So I'm going to be writing here, I'm just going to be highlighting this part. Okay, so now you can see that I'm going to be writing log to the base of 10, 500 would be equal to x. Do you understand? Just like here, they have given 10 raised to power 8 minus 4. So now that 10 raised to power 4 is 10,000 times as great. So any kind of exponential increase you can see in the graph here. Now 500 basically represents that you have to arrive at this figure. How would you arrive? How many times do you have to multiply 10 so that it can give you 500? So if it is 10 squared, you can know that it is 100. And if it is 10 cubed, then you know that it is 1000. So that means it lies between 2 and 3 the power, which can give you 500. And we can say that y is equal to 10 raised to power x, because we don't exactly know the value of x in this case. But we are just estimating that it's going to be lying between 2 and 3. And this exponent is going to be giving you a power till it reaches this point. You are not going to go up because that is our prime objective, that we want to find how to arrive at 500. Now I'm going to be telling you how to, place this in the format of, like I told you, this is the base. This is how you basically represent the base. Now the main exponential function will be y is equal to bx, b raised to power x basically, and that x is the exponent, or b raised to power x is equal to y. You can write either way. Now, like I said, that you have to, this base, you will attach the log function here, just like they have attached the log function to the base b here, and then you multiply, it with x. So now, in this case, you have log, you will basically multiply and you get the power to the other side. So in this case, you have, so log to the base of b into, if you have some other function here, and then equal to the power value that you have. So now, let's say that this is y in this case, the power we have. So y you're going to be writing here, this. So power, when you're converting into log function, you will bring the power to the other side. So on one side you have the power with you, and so it's going to be log into that other function that you have, which is x, is going to be brought here, and log to the base of b into x is equal to y. Now y will be the power function. Okay. Now we have, for instance, value here is 2 raised to power 5. You can just convert it. It's 32 is simple. You also need to remember that b has to be greater than 0 and it's not equal to 1, because we have already done that before. And let me just repeat that. Anything which is raised to power 1, it just continuously gives you 1. So now this is that, just write this, just you have to remember that the detail is that the main function is basically by is equal to x. So now you will have log on both sides. You can just simply, mentally do that, So it's by is equal to x, so log to the base b into x is equal to y. Now y will be your power. And similarly, you can just replace x with some other value, which is c, and in this case it can be a constant or whatever the value is. It means that basically this opposite is the power. So you have here the mechanism in a little, if you want to understand from the point of asymptotes and how you're going to interpret this on the coordinate system and the real line number. So you should know that the range would be the entire real line number line, which is from negative infinity going towards the positive infinity. And then we can have any constant value, which could be having some c variable, or it's going from that particular value to infinity. Now it could be negative as well. So if it is a negative, let's suppose it's negative c, it's going to be going from negative c to infinity. If it is positive, then you're going to be writing positive c to infinity. So we have the x axis, and then we have the y, in which we can have the asymptote as y goes to 0, and x can assume a value of 1 as well. And we can switch basically values, and domain, you should remember that we'll have the base b for the log function to be applied. We can look at some examples here. Okay, so you can just read up on how to convert back as well. Anything like I said, since it is already represented in the log form, this has to be the power. Then base would be multiplied by the power, and this would go on the other side. And if you have to convert back, then you can just simply practice that it has to be log to the base b into x is equal to y. So on, in either way, you will have the power on the other side, or you'll have the x value on the other side. So if in this case, they're asking you to write the, function which is already in some, we have write it in some exponential form. So you can just simply see that this is the base. So if this is base b, just replicating this, base b to y. So this 6 to half, okay, and would give you equal to under root, then 6. And that would be 6 raised to power half would be under root 6 raised to power half, because under root is also half. So now this is 6, and I just repeat that again, like b, this is b, this is y, like this is half, okay. So now I have 6 raised to power half equal to 6 under root, which is 6 raised to power half. So now you should know that if the bases on either side, the left hand side and the right hand side, are the same, then the exponent would be the same. So in this case, the x, so 6 raised to power half, and then is equal to 6 raised to power half. So then, as you can see that this is b is equal to, here, b is 6, okay, because this is the base. And y, this is y, which is, in this case, this is y. So you can just look at this entire equation, and then again b is equal to 3 here, and y is equal to 2 here, and then we can have base raised to power 2 is equal to 9, and obviously even 3 whole square is equal to 9, so this equation is correct. Then we have the exponential form of again base raised to power, so then you can maybe make sense easily here that you have base multiplied by the power to give you this value. So it is 1 million. 10 raised to power 6 is equal to 1 million. 5 raised to power 2 is equal to 25. Again, you can just convert it back. So now, there's another example for you. Alright, so there will be certain questions in which you have to, do it without the calculator, and then there will be other questions in which you will be required to directly calculate. If you can just simply, without the calculator, just put in the values and find out, or just express it in the log form. So now this is already this is the base now. So I have log to the base of 2. In this case, this is base to the base of 2 into 8 is equal to 3. So log to the base of 2 into 8 is equal to 3. Similarly, this is log to the base of 5 into 25 is equal to 2. And I told you that the power has to come on the other side. It's always on the right hand side. And in this way, you can just simply, see that you have to, first of all, convert it into, in the fraction form. And then now you can find that this is the base again, and this is the power is basically at this time is minus 4. So, and this is approximately equal to y in this case. So now log to the base 10 into this is equal to minus 4. Or now log to the base 10 is basically log. It's as simple. You just don't have to write the base 10. When you don't write it, it is just understood that it's going to be the common log, and the terminology is common log. And into this is equal to minus 4. Okay. Now you have the other equation, as I'm sure you can express it in fraction form. You can evaluate these functions, knowing the squares and cube and root allows us to evaluate many logarithms mentally, because we know that 2 raised to power 3 is going to be 8. So what they mean by mentally is that things that are easy to decipher or comprehend mentally, that you can just don't need the calculator for that. Now again, this is the same thing. You can just mentally exercise with this. Okay, let me just go ahead. Now, they say that, solve y is equal to log 121 into 11, and you can just simply, put the y on the other side. So it's log 121 into 11 is equal to y, so you know that this is the base now. So this was, and the power, so the base into power, so 121 y is equal to 11. So this is, I can do this. Similarly, you can just see here that you have log 464 is equal to y. So you know that this is the base. So 4 raised to power y. Similarly, you can see that this is 121. So it can be raised to power something. So you can just get this value. And on the other side, it's always the power. So it's 4 raised to power y is equal to 64 in this case. So 4 raised to power 3. So in this case, y would be, or 4 raised to power x. Anything the power is going to be 3. Now you can just assume whatever power it's going to be. So this is just basically an inverse function. And you have log to the base of something into this is equal to y, and you just have base. So it's going to be some maybe fraction form, which can give you back the original number. Now we have another fraction form, log to the base 3, 1 by 27. You know that this is basically 1 by 3 or 3 raised to power minus 3. See, and see, this is 3 raised to power minus 3. So log to the base 3 is equal to some function. So 3 raised to power y is, this is 3 raised to power y would be 3 raised to power minus 3. So y in this case would be minus 3. So log is equal to minus 3 because we assume that this whole thing is equal to y. So when we say that y is equal to minus 3, then log would give you minus 3. Okay, again we have this value. So I hope that you can understand this first one because we assume the entire equation to be equal to y. So when we find that y is equal to minus 3, then we can equate the whole equation to minus 3. In this, you can see this is again the base. And we have a fraction here. You can just maybe compute on the, with the help of your calculator, you just do mentally that it's 2 raised to power 5, and they've already mentioned this before, So 2 raised to power 5. So if you just take it in the numerator side, it's going to be 2 raised to power minus 5. And so 2 raised to power y is equal to 2 raised to power minus 5. So that in this case, since 2 raised to power y, I repeat this. So 2 raised to power y is equal to 2 raised to power minus 5. So when the bases are same, the exponent will be the same. So when 2 raised to power y is equal to 2 raised to power minus 5, that means that y would be equal to minus 5 in this case. So you can equate this entire equation as equal to minus 5. You can also try it on your calculators to find this out. And now this is just, they've already told you what I've, mentioned before, that common log is to the base 10. And then there is something which is, I think that's going to be, a bit ahead, where they have, excuse me. So now we have log of 1000. See, in this equation, they have not mentioned the base. So as mentioned before, I'll just reiterate here that if something is not mentioned in the base, it automatically means that it's 10. So log to the base of 10,000 multiplied by 1000 is equal to y. So 10 raised to power y would be 1000. So it's going to be y is equal to 3, as you can see here. Now 10 raised to power y is equal to 10 raised to power 6. So y is equal to 6 here. Is that if you need to directly calculate from a calculator, then you can just simply press log first. So when you press log, if you do it through your mobiles, then it's just going to put it in the bracket, and then you can just press the digits, and then, but if you have some other scientific calculator, then just simply press log and the values, and then you can just press enter. And you can round it off to 3 decimal places, or as per the requirement of the question. So what you're trying to analyze here is, the purpose is that, like we've done before, that if in case you don't know what this is, 321, because you know that 10 square is 100 and 10 cube is 1000. So between 2 and 3, it has to be between 2 and 3. So when we press log, you can just simply estimate that, because this was to the base of 10. So that means we could use 10. You can't always, arbitrarily use or, select a number to, put as base. Since it's a common log, then, we could use the base 10 in this case, and we could estimate that it was between 2 and 3. We have done this. You just simply see that we have to the base of 10 raised to power x is equal to some value of 500. And we can't really assume from which to which value, because it's from, again, 10 square to 10 cube. So that would be again between 2 to 3, and it's going to be 2.7. So we have then the natural log. And natural log is an exponential value. And e raised to power x, or you can express it as e raised to power y. So when this ln is mentioned, this connotation is e, log to the base of e, and then of x. That means that you're taking this as the final number to which you're going to raise the base's power. Okay, I'm going to repeat that. This is the final number which you're going to obtain when you raise the base b to a certain power y. And then it will give you as final value of x. And how you're going to express it as is now e raised to power x, because now our base would be, in this case, e. So log of e, so then it's going to be e raised to power y is equal to, then you can have x. And do know that in this case, e, if raised to power 0 would be, it has to be greater than 1 and would be equal to 1 perhaps. So x has to be any value which has to be greater than 0 to give you any other meaningful number. You can even calculate that as anything which is raised to power 0, because the value of e is 2.718282. So any number which is raised to the power of 0 would basically give you 1. Now this again is the same term, except that now we don't have the base 10, we have e here. And you can just simply do it in the calculator, and you can just express it in the form that we have done before. Now we have the exercise questions, and I expect that you do all these questions. So then I'm going to be discussing, partially some questions, turn by turn. For that I need the board, and let's just switch to the board right now. I'm going to be writing this question. So let me just write the question first for you. Question 1, which is the verbal section, is that what is a base b logarithm? Okay. I'll just write this base b logarithm. So what's, like I told you that, they've given you, they say that discuss the meaning by interpreting each part of the equivalent equations. Now, the equation that they've given is, the first part is that b raised to power y is equal to x. So now you see that when b is raised to a certain power, raised to, this is, we don't have any, do we have substitute marker? Raised to a certain power. To give you the value of your choice. The value of choice, or the objective that we need to find out. And b has to be, it cannot be equal to 1 and has to be greater than 0 in this case, because this is the base. In other words, this is base. So you can always give an example that, if 4 is the base, in this case, so if 4 is greater than 1, so if b is equal to 4, then you can have 4 raised to power some value x, which can give you maybe 64. Now, we need to find out that what this value could be. So in this case, we already know that this is 3, and then that gives you 64. So now, our objective is to find that any number can be multiplied with an exponent. This is an exponent. So any number can be multiplied by an exponent to give you the final, or main number of choice. And the next part is log bx is equal to y. Log bx. Bx is equal to y. Now again, this is the form in which we want to find out the value of x, basically. So now you can just simply, this is the exponential form and that is the log form. So how you interpret it basically is that when you apply log to this equation, so when you apply log to equation, and this is equation 2, so we can apply log to equation 1 on the right side, then we actually, when you have something like that, it can be written as y log b, basically. But we are not going to be doing this at this time because we need the power on the other side. So then, what we do is that, so log to the base of b, so we are going to be shifting the power here in the lower part. Like I explained to you, this is the coordinate system, this is negative, and this is the positive. So just simply indent it a bit vertically downwards, and then into x, which is on the opposite side, equal to y. Now this is the power. So then you can express it as equation 2, which is a form of the power form of equation 1 in this case. The next question is how, okay, let me just rub this and first of all write the second question for you to understand. You can always go back to your chapter and for reference purposes, and you can write that down. It says that how is the function related to exponential function? What is the result of composing these two functions? So let me just write down the function. So this 2 is, and this is page 497 of your chapter. And this is, the book is basically OpenStax, trigonometry, algebra and trigonometry. Okay. First function in this case is fx equals to log bx. Log bx. And the second function is gx. So this is 1, and the second function is gx is equal to, okay, and that is b raised to power x. B raised to power x, yes. So now what you're saying is that you need to compose. So how do you answer this? Composing basically means that, either you can replace the value of one instead of the other, or you can express one equation in terms of the other equation. So we are going to be expressing our equation 1 in terms of equation 2, or you can just simply say that you can be replacing the values. So function, in this case x, let's just assume this gx. So f gx in this case would be log. So now I can just simply say that this is log of b, and then this is, since I can assume that this is equal to x. Okay, so now either you can just simply say that this is log bx is equal to x. So you can just simply compose, or you can express it in this form. Since I say this is a function which is going to be expressed, x is going to be expressed as gx in this case. So now function of gx would be giving you log with, this is the value of basically x. You can have, this whole function. I have designated that this whole function is basically equal to x. So now this function, when replaced inside this value of log bx, can give you basically that function. Gx would be again expressed as log of bx, because you can just even write it as log of, to the base of b, and then into x, and can be equal to some other value, which is either some small letter x or n in any way. But when you're replacing one value into another, you can just simply, since this is already gx, so this is, when you're replacing this value inside this value, this will already have this log of gx basically. So then you can just simply say that this is equal to, this whole value is equal to x. You can just simply equate this as equal to x. Okay, let me just see one thing. Okay, now let's just move on to you can do other questions if you feel like it. Let me just verbally tell you, there's how can the logarithm equation log bx is equal to y be solved for x using the properties of exponents here. So basically they've just given you a logarithmic equation of log bx. Log bx is equal to y. Okay, this is 3. And what they're saying is that solve for x using the properties of exponents. So we already know that we have to bring it to the other side, would be equal to, or you just simply, since this is the base and this is the power, you just simply put it as that. So you can now find out the value of x could be equal to this equation. And then the third, I'm just going to be verbally discussing this. Okay, this is. That was question 4th. Is discuss the meaning of common logarithm and what is the relationship with base b. So the relationship with base b is that in this case b would be 10. So it is not written because it is common, and log to the base b in this case would be log to the base 10, and we would skip writing 10, and the notation is going to be just log of that value, maybe just log multiplied with x. Now part 5 says it discuss the meaning of the natural log. So log ln basically is log to the base e. I've already mentioned this. You can just go back to the chapter and read about it. Now let me just go and quickly just skim through these questions. Rewrite each equation in exponential form. So now question 6 starts with exponential form, and it says that log of 4q is equal to m. Log of 4 is to the base 4, and q is equal to m, and just put it in bracket. Okay. Just now we know that this is the base, so 4m is equal to q in this case, and that's all. Okay, because we don't know if it had been some number, we can maybe convert it into power, and then we can just simply equate this. Then we have another question. It says log ab is equal to c, and then simply log a b is equal to c. Then again you simply convert it into power form, is equal to b, and you just put the bracket, or it's fine, you don't have to necessarily put a bracket on. And 8 says that log x64 is equal to y. Log to the base x64 is equal to y. In this case, x can be raised to power y to give you 64. So now x can be any value. If it's in number form, then you can just maybe equate this. This is how you convert it. Then okay, you can do other questions along with it, and the same the ones that are following the same pattern. There's a negative one, which is question 10. Maybe I can just simply. It shows that log yx is equal to minus 11. Log y x is equal to minus 11. So y raised to power minus 11 would be equal to x in this case. So the negative integer should not be confusing. Okay, now then there's a case for log v is equal to t. Log v, is it in the power? Okay, this is log v is equal to t. Like I said, that since this doesn't mention the base, so automatically assume that this is we have 10. So you can just simply write this is log to the base 10 of v is equal to t. So then base 10 raised to power t would be equal to v. It's as simple as that. Then we have natural log of w is equal to n. 15th says log of w is equal to n. Then you know that this is log of e, or you can just simply write it as log to the base of e. W would be equal to n, so e raised to power n would be equal to w. Now rewrite in logarithm form. Okay, now you have to do the reverse in this case. Few questions in reverse. Okay, so now it says that 4 raised to power x is equal to y. And this is question number 16. 4 square x is equal to y. So now this is already the base. So you know that log to the base of 4 into y will be equal to x, because I told you that we have to bring the power down here. Then there's some fraction form maybe I can do for you. 7 by 5 m is equal to n, and this is 22. 7 by 5 raised to power m is equal to n. So again, you compare that as, you just simply equate it as b. So log to the base b. In this case, first of all, just write it in the log form. Log to the base b of n is equal to, this is m actually. So the n is equal to m, and you can't just have the equality on both sides. So now we can just simply replace b is equal to 7 by 5. Therefore, replacing it, you're gonna get log of 7 by 5. N would be equal to m. Then you have other values which is similar to this, or akin to this. Can go over all the other questions. Let me just see if there are some different questions for me to do. Okay. For the following exercise, solve for x converting the equation into exponential form. So we have, let's say, question 32 and 33. So I'll be requiring my calculator for this. Okay, so this is 32 says the log to the base 18, x is equal to 2. 32 says the log to the base 18 into x is equal to 2. So now you can just simply write that 18 square is equal to x in this case. So since they've asked you to solve for x, you can just simply multiply and you get 324. So x in this case is 324. So there's a question with just simple log x is equal to 3. Log of x is equal to 3. You already know that this is to the base of 10. So 10 raised to the power 3 is equal to x. And you know that x is equal to 1000. Similarly, you can do all the questions that I've done. You can do the similar ones. You can practice on those. And then there's some different ones a bit like this question 36. Now it says for the following exercises, use the definition of common and natural logarithms to simplify. So now here this log 108, so log 100, this is 36. Log 100 raised to power, so it's 8, or 8 or 6, is 8. Now, okay, this is something which requires a different technique. We already know that you can just equate it. Even if they're not mentioned it, you can just simply equate it as x. I'm just going to be rewriting it as log to the base 10 and 100, 8. So this is basically log to the base 10 and then can be equal to x. Now perhaps it's easier for you to work on 10 raised to the power x would be equal to 100 raised to the power 8. Now again, I told you that when bases are the same, then the exponent value can be it can be found or it can be computed. So now you can just write as, can you just convert it as a square and then 8 lying outside the square, and we know that the power principle, it says that you can just simply multiply them. So it's going to be 10x would be 10 raised to the power 16. So in this case, since the bases are the same, so x can be equal to 16. Okay. In a similar fashion, there's another question, 41. Okay, it seems to be a bit different. E log 10.125 plus 4. e raised to log 10.125 plus 4. So now we can assume in this case we have a heavy power. So you can just simply, let's just assume that log of 10.125 is equal to x in this case. So now then we know that this is to the base of e, so log, generally I'm explaining to you that this is log to the base of e 10.125 is equal to x or ex in this case. So now this is e into x is equal to 10.125. Now since we have assumed already that this whole thing is equal to x, so we can again we can just replace the value here. Then e raised to power x, now just replacing the values. We just simply write that since e raised to power x is actually, this whole thing is actually equal to 10.125. I hope you can understand the connection that since we've already put the formula that ex is equal to 10.25, we have just reconvert that into exponent form, and then we already have the equation as e raised to x because we have assumed that this value is equal to x. So then plus 4, and you can just find out this is equal to 14.125. So in this case, this whole equation is equal to 14.125. Now we can have question. Okay, there are other questions as okay, there's a question 48 for instance. It says log 1 plus 7. So now you can just simply either find out what the value is of log 1, but you just simply it gives you 0 value. Okay, so 48 simple that log 1 plus 7 would be 7. Okay, because this value is equal to 0. Now I hope you can do these questions. They're pretty easy to attempt. Next we have technology. Okay, so for the following exercises, let me just okay, for the following exercises, evaluate each expression using a calculator round to the nearest thousandth. So you can just simply 54 to 58 questions are from calculator. You just press log, and for 54 question you're going to take the common log, log. The option in the calculator is for log, and then for 55, in which it is ln, you just take the natural log, which is ln. So you don't be confused in the notations. Then there is an extension question 59. Okay, so it says that is x is equal to 0 in the domain of fx is equal to log x. Or they want to say is that if x is equal to 0 not is. Or maybe it's just a question, maybe they're asking you that is x 0 in this? So if so, what is the value of function when x is equal to 0? So, so you know that if x is equal to 0, then you can just simply find out that what the value can be of, in this case, can you have zeros? You can just simply get infinity. It's not a very clear-cut result in this case, because anything which a log of 0 will be not defined in this case. It's going to give you some infinite value. Let me just log of 0. Yes, it gives you a negative infinity. So in this case, it's not going to be defined. So is x 0? It's not necessarily that x is 0 because it is equal to some function. So you can't really verify it in this way, that if x for anything to be 0, the function has to be having that this whole function in this case would be zeros, not just x. So log, you can't just really place this value, you can't really find it out from this function is that x is 0, because then this function won't have any value in this case. So you can't have log of a 0. So it is not possible to have. So it might be that this domain does not have x equal to 0 in this case. And then there's a question that, okay, this 63 is a trick question. It says that log of e raised to power 1.725. This is 63. And it says, you have to verify this, that log of e 1.725. Log e 1.725 over log of 1. Now, this is 0. Okay, so log of 1, we've already, whether it's log or it's natural log, it's equal to 0. And we already know that anything, I'm just going to bring their distance so you don't get confused. Anything which is divided by 0 is infinity, so this is undefined. So you can't really verify this result from here. And there's question 62. Okay, so anything in power, basically they're just asking you to verify this result. Okay, let me just. There is question 62. Let me just write this down. Rub this. It says that log 3 of 27, log to the base 3, 27 over log 4, 1 by 64. Log 4, 1 by 64 is equal to minus 1. And you have to verify this, okay? So you can just assume that this, first of all, you can just convert it into equation 1, equation 2, and then log 3, 27 would be equal to x in this case, so 3 raised to the power x is equal to 3 raised to the power 3. So x in this case is 3, and since we have assumed this whole equation is x, so you can just simply place, and for the, this is part 1, and part 2 is log 4 is equal to maybe, a y or something, so it's log 4 in this 1 by 64 is equal to maybe y. Okay, let me just assume it as y. So now 4 raised to the power y, 4 follows that 4 raised to the power y would be equal to 4 raised to the power minus 3. Okay, because we know that 1 by 64 is 1 by 4 cubed. And when it goes up, it's 4 raised to the power minus 3. So now you can just put in values, and we have assumed that this whole equation is equal to y. Then simply that it goes to the next step will be here. Then it's 3 over minus 3, and that is equal to minus 1. Okay. Then we have some real world application. If you have any problem in other questions, you can just simply ask your fellow mates, just refer to the book. Or you can just drop in a note or something on Google Classroom. So, but you have to be very specific in your queries. You can't just generally ask questions that you didn't understand the whole lecture, because you have to be it's not possible to disseminate the entire information to every student. So you have to be very specific in your inquiry, whatever the query may be. And this question, okay. So this problem here, and it says that the exposure index EI for a 35mm camera is a measurement of the amount of light that hits the film. And they've given you some equation. EI, which is the exposure index, is equal to log to the base 2 f squared by t. exposure index. So this is question 64. It says EI is equal to log 2 F2 by T. Okay. So now what have they asked us to find out? Where F is the f-stop setting on the camera, and T is the exposure time in seconds, and suppose the f-stop setting is 8. And since we have F as f-stop, so F is equal to f-stop is equal to 8. That means that f square would be equal to 64. And how much is the value of, and the f-stop setting is 8 and desired exposure time. So the value of T is 2 seconds. T is equal to 2 seconds. 2 seconds. What will the resulting exposure index be? So in this case, EI would be log to the base of 264 by 2. So now you can just simply, at first you can just simply, cut that as, simplify it, I would say. Just 32. So EI is simply, you can just say that this whole equation is equal to x. So 2 raised to power x would be equal to 32. And now we know that this can be as 2x is equal to 2 raised to power 5. And x in this case would be equal to 5. So that means that our exposure index, because this whole equation that we have equated to x, then it means that this is actually equal to 5. Okay, so now you can do other questions in this, there's, okay, there are not many questions here. I'll just do the last part, maybe it's just a bit confusing for you. You can do the question 65 in this case. You're just supposed to find out, the value of -2 in this case. You can just simply see that this is EI, just let me just read the question that refer to the previous exercise and suppose a light meter on a camera indicates an EI of -2. So in this case, you're just going to be simply, replacing the value of EI as -2, and you'll have the whole equation as the same. You're just going to be finding the value of f squared, whereas T you already have. So, so it's just going to be something like, -2 is equal to log to the base of 2 maybe, and then you're going to be having f squared over T, which is, this is already 2. So now you can learn how to solve this entire question, because you can just simply, first of all, find out that this is the base, and so anything can be equated equal to x, and x is equal to, or you can just simply, find out, since you can just equate it as x, and then you can just finally find out the final value, which would be, in terms of f. Okay. So I hope you can just understand this, and they have given you, in this case, desired exposure time is 16. Okay, so in this case, they've changed the value of, T as 16. Okay, so you just simply like this, log to the base of 2, and then you can have maybe 16. So this should not be much of a problem for you. I hope that this is your assignment. Okay, now please just make sure that whatever questions that I have not done, these are supposed to be your assignment. And this last question I'm going to be doing for you, maybe this can confuse you a bit. So this is basically, seismograph. And this question says that this is the intensity level of two earthquakes. This is measured on a seismograph, can be compared by the formula of log I1 by I2. Log I1 by I2, and this is, I think this is entire log, yes, is equal to m1 minus m2. Now this is question 66. And whether m is the magnitude given by the Richter scale. We've already discussed the concept of Richter scale. In August 2009, an earthquake of magnitude 6.1 hit Honshu, Japan. And in 2011, the same region experienced yet another more devastating earthquake, this time with a magnitude of 9. So now we can just assume that m is the magnitude, and since we have to find out the difference between the magnitudes, so we'll take the later value as m1 and the former value as m2, because that's the original value and that is the lower value. We don't want to have a negative value. So we're going to be just log of I1 by I2 is equal to, so this is 9 minus 2.1 in this case, because this is the magnitude of 2011 and this is in 2008. So now this log I1 by I2, you're going to just compare it as, you can just equate it as, for safety, just as some fraction equal to x, or this value is okay. Oh no, this is 6.1, sorry, 6.1. 9, so yes, this is 6.1. Okay, so I just, first of all, just find out the difference is 9, and 1 decimal less is 2.9. Okay. So now you already know that this will be to the base 10. So anything which is raised to the power of, to the base 10 would be expressed as I1, and this whole, like I said, this is some value x. You can just simply write, and then you can replace the value of x as I1 by I2. And then, since this is, okay, so this is 10, this is 100, and 10 cube is equal to 1000, so it's going to be 2.9 is close to about, but less than 1000, and more than 100 is going to be, it's almost 3, so it's, you can simply find out it's maybe just 800 around, but close to 800, or close to maybe 700 something, and then you can just simply multiply this value, so it's going to be I2 into 10 raised to the power 2.9 is equal to I1. Now, how are you going to interpret this whole thing? That it means that since the earthquake that came in 2011 was 10 raised to the power 2.9 times, and which I assume is maybe from close to about 800 approx, or maybe from 7, maybe late 700s to 800, any value in between. And then this I2, so that means it's almost approximately 800 times a value of I2. This was 800 times more than the original earthquake that happened in 2008 or 2006. So this is the way you do the questions, and basically discuss the entire exercise with you. Guys, you're supposed to do the questions which I have not discussed as your assignment, and you're also to do the exponent chapter, and I hope to see you next week. Thank you so much.